let me just take a second and I'll show you the antenna on this 7S682. This is a late version of the cabinet style wave magnet. Now this is not what they called a rotor wave magnet, and it didn't come in a cardboard box like some of the other ones did. But this mounted instead in a fixed position inside the cabinet, just behind the chassis. So the chassis is small enough that there was room in there to mount this in the back of the cabinet behind the chassis. Now this one was pretty messed up. All the wires were all loose and were bunched up to one side of the dowels that they wrap around. So they were all gathered up here. Don't know why. And so they needed to be spread out. Now these wires, it's okay if they touch. These are coated in lacquer or some kind of coating. I'm assuming it's lacquer or some sort of clear enamel. Anyway, so it's okay if they touch, but it's better if they don't overlap. So, and it's better to keep the distances the same between them, but it's not actually critical because I've been playing this antenna and it works really well. And you see that these the distances aren't exactly the same. Now I did my best. Now this radio, guys, I got to tell you, I do fully restore my own stuff where I go through and I'm very picky about every detail. But some people just bring radios to me and they just want them repaired. They don't really want them restored. They want them repaired. And they want the essentials restored, but they want the radio to work. They want it to be reliable. They want it to look decent. And they want to be able to demonstrate it to their friends. Details like this, you know, they're not willing to pay for my time to completely remove this wire or to lift it off and clean all this stuff, the glue off underneath them, and then lay them out and measure exactly the distance and all that. I would do that for my own radio. But then again, I get my time for free. But folks that want just a good radio that works and that they're proud to play and that's going to work forever. I mean, whether these wires are perfectly spaced or not isn't going to affect the longevity, the how long this radio lasts, you know, before it needs service again or before it, you know, dies. That has nothing to do with how long this radio will last. So they're not really that eager to pay for my time to do all of that. So what they would rather have is they give me a pretty mangled antenna, missing nuts and things like that. And what they'd rather have me do is make the antenna work, make it work well and reliable so they don't have to fiddle with it, and be done with it and move on to the next part of the radio. So that's what I did on this radio. So if you're kind of looking at some of this work saying, that's a little messy, or I would have been more particular about that. Yeah, I'm sure, you know, a purist would. And when I do my own radios, especially, I'm getting ready to start 1931 GEH31, and I'll be really particular about that because that's a classic radio, and it's the kind of thing that I want to be perfect. But this radio, it's something that the customer, you know, they pay a lot of money for this. Instead, I prefer, and they prefer, that I give them a good deal, and they get a nice working radio out of it. So anyway, let's go on with what we're looking at here. So Zenith set these up so you could hook up an external antenna as well as the wave magnet. So you have a jumper that you sometimes can use, and you'll see it on the schematics. But what I really wanted to show you is that what this is basically a transformer. John in Arkansas alluded to that in one of these that he did. And the inner loop is your typical, you know, higher impedance loop antenna, lots and lots of turns of fine wire. And it actually receives the signal from the air, okay? And then it is magnetically coupled to the outer loop, which is the actual part that connects, that has leads connecting to the radio. So here's how Zenith showed it schematically. So this part in here where it says 65 ohms, I say high impedance, a lot higher than 1 ohm of the outer loop. So 65 ohms, that's the inside loop. That's the small loop about the size of a coffee saucer. There is a capacitance across that loop, and that thing is connected, excuse me, that thing is connected to, now I went and screwed myself up. Okay, that's connected to these leads here. My cat was distracting me. These leads here, so if you want to connect an external antenna, you'd connect it to that A, and I believe you would remove this little jumper. but I'm not sure. I've not messed with it, so, and I haven't given it a lot of thought. I probably should. But anyway, so the outer loop, this part out here, is connected into the radio. It goes into the antenna. You know, it's got a loop loading coil for impedance matching, and then it's connected up into the radio, into the RF stage. So that's how they work. It shares a ground. There's some of these actually had foil on the outside, and there was a ground attached to it for shielding. This one did not have it. I don't know if it ever did. I've seen pictures of these radios that didn't have it. I don't, unless I'm missing something, I don't, it's not needed. It's not connected to anything. I don't see any shielding, but it doesn't appear to be needed. So this is the back side of it. There's that 50 picofarad capacitor in there. There's the one lead of the small loop antenna that's connected to this this lead right here. As you see right here, it connects out to the antenna lead. That's if I want to run an external antenna. So if I want to run an external antenna, there's a lead that it comes off of the connector for doing that. Now, I'm not a radio engineer, guys, so I don't know every detail about how this is supposed to work. I probably ought to research it before I start yakking about it. But what I really wanted to point out is, because I had a heck of a time trying to figure out how do I connect all this stuff when the leads were all pulled out of the connector. So here's how you do it. And then you can sort out, if you're that sort that wants to, you can sort out just all the RF theory of why it works. Okay, so if you look at the connector real close, you'll see that there are two pins that are closely spaced and two pins that are more widely spaced. The two closely spaced pins, this is a Zenith now, other ones would be different. Two closely spaced pins have leads that go right to the outer loop, the heavy wire low, the 1 ohm loop. Okay, I'll show you those on the schematic. So I numbered the connector pins just for myself. I don't know if that's how they would otherwise be numbered, so I called them 1 and 2. And these leads from the outer loop I called those two narrowly spaced leads, those two narrowly spaced pins, 1 and 2, they're connected to the outer loop. Now, if you'll look here closely again, you'll see that you've got one side of the inner loop that's connected to a lead that is intended for the external antenna, like shortwave, whatever, because this doesn't work with shortwave. It works only with broadcast band. So you connect an external antenna for that, and so it connects to that small loop. It also connects directly to the antenna coil, the antenna coil in the radio. Okay, so that one is, I called that connector number 4. So if you look at this, now I put little marks on the outer edge. So 3 is not used on mine, okay? And 4 is where I connect those two leads, one for the external antenna and one that goes to that small loop. Okay, so if you look at the connector, starting at, boy, this takes some practice. Hats off to those that have been doing it for a while. If you start at the narrowly spaced pins, pin 1 is the one that, if they were at the bottom, would be in the lower right hand location. Okay, going around from the top view, going around clockwise, pin 2 is the other narrowly spaced one. You see two hash marks on the edge of the connector. Pin 3, going around clockwise, pin 3, come on camera, focus. Pin 3 is not used, okay? And then pin 4 on my numbering scheme is the two leads, one that goes to the loop and one that is a lead for the external antenna. So that's how you connect up one of these guys. The ones in the cardboard boxes are pretty much the same. I hope this is helpful to you. Like I said, I'm not a radio engineer, so to explain the theory, I still have to figure out why leaving this jumper across here makes this work. Boy, maybe one of you in your comments can explain that to me. I'm an electrical engineer, but I focused on control theory stuff. So I'm learning all this. This RF stuff is sometimes seems like a little bit of magic. The way this works seems like magic to me. I'm not sure how that happens, but it's on all the zeniths of the period. And because this antenna did not have the jumper, I just implemented it with a piece of heavy copper wire. Piece of cake, man. So let me know what you think if you know how that works. Otherwise, at least I can show you, in case you've been wondering, how that antenna is wired up. That's all for now, guys.